Hello, I'm Syachrul, and I want to introduce Climos-D2S satellite for measuring CO2 levels and monitoring vegetation area for carbon credit using spectrometer and high-performance multispectral camera. Climos-D2S satellite is a 6-unit CubeSat, which is a constellation that combines two different inclinations to detect CO2 emissions and monitor vegetation areas for support the system of carbon credit. The Climos-D2S satellites constellations move onto orbit. That is a ISS orbit, and the equatorial orbit, where there will be orbiting on each orbit line. The Climos-D2S satellite will support the system of carbon credit as a validator to help the unmatch of the CO2 emissions with the availability of forest that is able to absorb it. By gather information of CO2 emissions, as well as forest area, to provide the comprehensive information to support the carbon credit programs. This project is done by 4-member team with Dio Widiantono, Diva Aulia Zulkarnaen, Salya Al Fathurrahman, and myself. We hope by the end of these presentations, you get an insight of what is the project developed. First, I want to talk about the mission overview. In 1994, Indonesia's total CO2 emissions was around 100,000, while the CO2 absorption by the forest was approximately 300,000. Distributions of CO2 levels per year 2021 with a total of around 30,000 empty CO2, where the black circles in the figure are CO2 emissions levels in each country. In a short period between 100 till 1,000 years, an increase in CO2 in the atmosphere can affect the Earth, such as higher average temperature, irregular rainfall patterns. Even increased CO2 level can also cause change in organic materials, returns, and reduce soil moisture. Solutions named carbon credit is implemented to combat this problem. Carbon credit is a system where a certificate showing that a government or company has paid to have a certain amount of carbon dioxide removed from the environment. However, there is a problem with the implementations of these solutions, which is the monitoring of the emissions and the forest area, which are not integrated into the system. For that, we propose constellations of small satellites that gather information of CO2 emissions as well as forest area to provide a comprehensive information to support the carbon credit programs. Overall concept of operations of the spectrometer payload is to measure CO2 levels, and for the camera payload is to capture image based on vegetation area. The working scheme of Climos-D2S is first, the ground station sends commands to Trisco TTC and data is calculated by Trisco OBC. When the Climos-D2S points the location near Indonesia, the Trisco OBC automatically turns on the spectrometer and measures the CO2 level. CO2 level data is stored in a flash memory validated by Trisco OBC to calibrate the satellite's accuracy and define a multispectral camera to capture the vegetation area at a specific point in time. According to the ISS and equatorial revisit time, the payload can scan target for up to 35 minutes per day. Spectrometer and multispectral camera, the data are stored in Trisco OBC. If the satellite is outside the Indonesian region, the spectrometer and multispectral camera are turned off. However, this module can monitor other objects in other region. Next, we move to the Climos-D2S satellites interface. Climos-D2S satellites has 9 parts of component, that is, main structure, multispectral camera as a payload, spectrometer as payload, reaction wheel, star tracker, ADCS board, power supply, OBC and TTC board, and antenna. Next, we move to our payload and primary subsystems. For the payload of these missions, we use Argus 2000 spectrometer as our primary payload, who has field of view as much as 0.5 degree, with infrared range from 1000 to 1650 nanometer. and has spectral resolution as much as 6 nanometer as well. Next, for the secondary payload, we use Mantis Imager multispectral camera with large high-speed data storage. It's integrated into the compact design with flight height around 100 kilometer. Next, we move to our primary subsystem. It's included ADCS, TTC, OBC, and EPS. For ADCS subsystems on these missions, we use Cube ADCS. And for the electrical power subsystems, we use ISIS IEPS Type D. For the OBC and TTC, we use Trisco OBC TTC. And for the antenna system, we use ISIS deployable antenna system. For the solar panel, we use ISIS CubeSat solar panels. This is the power and data bus distribution of Climos-D2S satellites. The power supply delivers power into regulated bus. There is 3.3 volt and 3 volt, as you can see from the slide. Next, data interface. Data interface, Trisco OBC, store data with a several interface peripheral, such as I2C and UART, as you can see from the slide. And we calculate the mass and power as well. As we can see, the total power usage for these missions. Power supply uses 4 cells and is expected to be able to work on 4 scenarios. Those are standby, in normal conditions of power supply, 12 minutes of operations, normal conditions of power supply, and standby in case 1 cell failure of power supply, and 12 minutes of operations in case 1 cell failure of power supply. The total power consumption and mass budget of these missions is shown on the table. Next, orbital analysis. All trajectory analyses were performed using the Free Flyer software. According to the Integrated Space Debris Coordination Committee guidelines, the satellite must disintegrate within 25 years, at least 3 years considering the specified mission requirement. Next, a payload coverage analysis was performed to validate the coverage area over Indonesia. The coverage analysis shown in figure was performed with the constraint that the sensor only covered the area from 12 AM to 18 PM. Next is financial evaluations Climos-D2S satellite. For the development cost of the satellites, around $400,000, and the weight of the Climos-D2S satellite is around 3 kilograms, and planned durations at least 3 years. We hope you got the insight of our project. Every country has industrial areas and vegetation area that differ in size. Thus, it becomes a necessity that a central authority, usually a government agency, determines the limit or cap of the amount of carbon dioxide that can be released. Countries or companies are then allowed to emit greenhouse gases, in this case CO2, up to a limit amount. If CO2 levels are higher than this limit, then the country or company needs to buy carbon credit to be calculated with their emissions. If the number of the emissions is lower than the specified limit, then the country or company is allowed to sell the actual emissions and the allowable limit for them in the form of carbon credit. Something like that is called the concept of carbon credit. With this concept, the payload that we propose will have the main goal of being a validator to monitor in real time development of corporations on the carbon credit concept carried out by countries or companies with other countries or companies. Thank you for your attention. Have a good day.